Hey there, this video is about command line arguments in Makefile, two things that involve running our C++ code in, for instance, a Linux environment and being able to take things from that environment and putting it into our program. Makefile is also going to help us avoid needing to constantly say up, G++, up, a.out over and over and find some ways that we can better improve the way we compile and run our programs. We're going to do the first half of this lab using, this exercise is using command line arguments, and the second half we'll talk more about Makefile. So first off, in our first exercise, we're going to make a program that takes a simple molecule like H2O as a command line argument and outputs the number of atoms of each element in the molecule. Now, one thing we're going to do is we're going to first of all assume there's no more than 9 atoms per element to keep things simple, and also we're going to assume there's hyphens in between each symbol. So H-2-O-1 should output H:2, O:1. We're trying to look for the exact same output. Now, this is a command line argument because when we run our program, we say /molecule counter, that's our executable, and we're trying to pass it a parameter to use in our program. We need some way for our C++ code to pick it up. So, in our videos, I gotta get rid of all this stuff, leftovers from before. Yes. We will rebuild these things real soon. Somehow got deleted already. That's clear. I'm going to clear these up. I guess I'll leave them for now. They'll come back later anyway. Okay, so example 1. Let's get this going. Include iostream, use the standard namespace, and we are going to make int main, but we're going to do something that we haven't done yet, which is we're actually going to have 2 parameters for our main. argc and character pointer argv array. What are these? argc is the argument count. It's literally how many things have been given to us through the command line. There's always one, which is the name of the executable, but sometimes there are more. argv is going to be an array that contains everything we were given through command line, starting with the name of the executable, followed by the first thing we type in after that, and so on and so forth. And to figure out how much is in this array, we need to use argc. Now, the first thing we need to do is make sure that if they enter something that doesn't have exactly 2 strings, basically, that they need to change it. So if argc is not equal to 2, then we will output usage, and this is what it should do, for example, and then we will return. And so basically, we're ensuring that if they are running our program properly, they have called it with some parameter that looks like this. Okay, so now I need to figure out what to do. And definitely, I'm going to want to take this and put it into a string. So string molecule equals argv1. Now, I think I may need to pass this to a string, just to double check. Before I go too much further, I want to make sure I'm not messing anything up just by printing out that it actually can collect this molecule. Let's try that before I go any further. So compile example, one. I have to return a value, of course. Return -1, that means I got an error. Okay, let's try again. So I'm using it wrong because I should use, and also I should probably build a executable called molecule counter. And now molecule counter H2O1. And hey, there is my H2O1 as a string. And now that it's a string, we can take advantage of all the stuff that strings offer us, namely being able to go character by character to figure out how to print out what the exercise is asking us to print out. So, okay, I got my string. For each character in my string, I need to figure out what to do. So for I equals 0, I is less than the molecule's length, I plus. And so I have 3 different things that I could get. I could get a letter, I could get a hyphen, or I could get a number. Now, if I get a hyphen, I actually just don't care. I'm just going to ignore it. It's not really relevant. So what I actually care about is actually a uppercase letter, a lowercase letter, and a number. If molecule I is upper, so it's an uppercase letter, then what do I want to do? I want to print it out. Now, I don't know if I want to print everything out right away. Maybe what I'll do is I'll build a result string, and I'll append everything to my result string. So result plus equals molecule I. If it is a lowercase letter, I actually kind of want to do the same thing. So if it is lower, also do that. If it's a hyphen, I do nothing. But if it is a number, what do I need to do? Every time I see a number, I need to have a colon, a space, the number, and then maybe a comma. I don't have a comma at the end, but I do have a comma after every other number. So if is digit, molecule I, then result plus equals colon space, then result plus equals the string version of the number. Or actually, no, it is it's just molecule I, right? This is our number. And then, is it the last character? If it's the last character, that means it's the very last thing, which means, you know, I'm done. But if I is not equal to molecule.length minus 1, if it's not the last letter, then result plus equals a comma. Do I have a space after the comma? I do, so comma space. And if I've done all this correctly, we'll output the result. Let's find out. Compile. Run H201. Hey, H201. What about MG1S104? MG1S104, and you can try with all kinds of other stuff, and it's going to work every time, at least assuming we have exactly the right format, which is very picky, and this isn't typically how we write our compounds. So in our next exercise, let's get it to handle a more useful format in the next one. Okay, in our next exercise, we are going to modify this program to support a -s flag, and when we see -s, this means that it will allow us to put in a simple format like this one. NaCl4 should say 1Na, 4Cl. Now we'll need to do some tweaking here because you notice it doesn't say Na1Cl4. So we'll need to write some code that will check out to see if this -s is present in our command line arguments. And if so, go through and add in ones where they need to go. So I'll duplicate my example. This is example 2. Okay, so now we need to check for a -s flag, which means we may have 2 or 3 arguments. So if it is not equal to 2 and it's not equal to 3, then we didn't get either one. So these are the 2 different ways that we can use it now. Now, if we're getting these 2 different ways of seeing it, that means that our molecule might be at argument vector 1, it might be the second thing, or it could be the third item. So first we need to check to see if argv, string argv of 1 is -s. Now I'm not sure if I have to convert to string or if I can just say if this is -s. I think I'll try converting it and just seeing if these match, but we'll play around with it to make sure. Now if this is the case, then that means our molecule is here. It is the third element. Otherwise, it's the first one. Now I need to make sure I declare my string molecule first, so that I can then assign it to be one of these 2 things. And before I go and handle all the situations, let's try to see if this was correct. So clear this up, compile example 2 into molecule counter, run it with H2O. Okay, so here it doesn't work because we were expecting, or hold up, does this work? Oh, sorry, this should be a 1. There's a little typo here. Sorry, here it should be a 1. I should be grabbing the second element, which is at index 1. Okay, let's try that again. Okay, so it grabs H2O, and then if I type in -S, it will still grab the H2O. So it'll grab it from the correct spot now, which is important. So now we can make sure that we know that whichever molecule we're working with, it will grab the right one. Now, I do want to do all this stuff. But if I'm looking at the simple form, then I have some work I want to do. I want to make sure that for the simple form, anytime there should be a 1, I can add it in. So what this means is that I once again kind of need to go through my string and figure out, hey, do I need to insert a bunch of 1s in here? So for I is 0, I is less than the molecule length, I plus plus. Okay, so now I need to figure out where does a 1 appear? And a 1 appears right before I see any capital letters, and also at the very end if there isn't one there. So now, there can't possibly be a 1 at the beginning because we have to start with a letter. But what we're going to do is we're going to look and see, okay, if molecule I is an uppercase letter. So if I have encountered an uppercase letter, then I need to check and see, hey, what's right before this? Is it a letter or is it a number? If it's a number, no sweat. If it's not a number, that means there should be a 1 there and there isn't. So if not is digit molecule I minus 1, if the previous symbol is not a number, then I need to put a 1 there. Which means I need to do some substring magic. So we have our molecule. Molecule equals molecule dot substring. And now I want to grab, starting from the first character, everything up to and including the previous one. So it's going to be, I believe I want to grab I minus 1 characters, and we'll double check the math on this. So I want to grab those first ones, then I want to add the number 1, then I want to add the remaining characters. Substring starting from index I to, how do I grab the rest of them? I think if I want to grab the rest of them, I can just put in I. That should work. And now this should put in 1s everywhere that I need them to go. Actually, I think this might be I, not I minus 1. Because this will grab the first I characters, which means it won't grab the one at index I. It'll grab everything up till including that. Oh, also, I want to do this only if we're at an uppercase letter. So if is upper, or no, we have is upper. Yeah, we have that already. Okay, yeah. If this and this. So the last thing I need to do is if molecule dot length minus 1, this is the last letter, is not a digit, then molecule equals molecule plus 1. And if I've done this correctly, what I've done is inject ones into all the places they need to be. So instead of NaCl, I should have Na1Cl4, which our code from earlier should be able to manage. So let's see if this works. I may have made a mistake, but we'll find out as we go, I suppose. Okay. No problems yet. Let's say H2O. Hey, H2O1. Let's do something more wacky. MgSO4. Mg1S1O4. NaClH2SO4. Na1Cl1H2S1O4. And hey, look at that. We have built our little molecule counter. Well, we could have done it a little better. And so in our next couple exercises, we'll see if we can improve on the way that we manage this, because this is really long code for a main function. I think we can improve. So let's take a look at that first. Okay, so first things first, we're going to start working with a Makefile. Now, we're going to make a brand new program for this. We're not going to worry too much about the command line stuff for this part. We'll come back to it later. But we're going to make some classes that will help us represent the things that we're working with right now. The classes are going to be element and compound. Element is going to have a symbol and a number, so H and then 2. The compound class will have a vector of elements. Write a Makefile for compiling these in a main function. So here, let's make a bunch of classes. Start with element.h, and this will have the stuff that an element will have, which will include IOStream and using namespace std, which is ideally not going to change over the course of us writing our program. The class is called element. We'll make it very simple. We're just going to say it's going to have a string. What does it say? A string symbol, an int number, and also conveniently we should have a function to display everything. So this is what an element is. I also need to have a compound. Compound.h is going to include element.h. The class is called compound. We're going to need to include vector. Also note that because I'm including element.h, these are included by default, so I don't need to write them in. But this will have a vector of element pointers elements. Okay. And we'll also have a display for this too. Now, there's not too much code that needs to go into these, but I will put the code into separate files anyway. So we'll have a new file called element.cpp, and in here I will implement this display function. So this display function is void display, but it belongs to the element class. So I need to say that it is elements display function, not compounds display function. And how does this work? Well, I will simply output, oh, and I need to, would help to include element as well. If I'm including elements so many times, I also should probably put pragma once here, because I will need it several times. Better to put it here too, just in case. And we will display the symbol, comma, space, or sorry, a colon space, number. Okay, so this will display each element. And then for our compound.cpp, this needs to include compound.h. And here I need to also implement display, but this display is the compounds version. And here I can say for what is it? Element pointer L in what did we call it? Elements? Yeah, elements. And now how do I want to display them all? Well, basically what I need to do is I guess so to be very careful about this one, because if I want to put all the commas in where they go, I gotta watch out. So maybe I'll do actually a normal for loop. I is 0, I is less than elements dot size, I plus plus. And we'll do elements dot at I. That will get us the pointer. Call the display method of that. And then if I is not equal to elements dot size minus 1, if I'm not at the final one, I also want to print out a comma space. Okay, so this should handle the printing of the stuff that I want to be able to print out. And I believe that it said also we want to have a Makefile for compiling these in a main function. First, let's get our main function so we can actually run this whole thing, and then we'll talk about building it. Okay, so main.cpp. So we need to include element.h and include compound.h. That's main. We won't have any command arguments just yet, but I need to now be able to make some elements and some compounds. So element E1 equals a new element. E1 dot symbol equals H. E1 dot number equals 2. Do this again. O1. And then compound C dot elements dot pushback E1 and E2 and display. To build this whole thing, which is a bit of a mess, I need to do the following. Compile element.cpp, compound.cpp, main.cpp into my molecule counter. Oop, I got a typo here. I forgot to put a semicolon after my classes. I should fix that. Semicolon. That's good. Hopefully that fixed it. Also, request for symbol. Maybe I meant to use the arrow for E1. I did. So these are pointers, so I need to use the arrows. Pointer, pointer, pointer. Okay. Clear this up. Try again. Okay. And now if I run molecule counter. Oh, not quite. It looks like we got an extra space here because I put in some spaces when I printed out stuff with my compound display. Yes, I don't want to print out end lines. I just want to print out the thing. Let's try that again. Now, before I go back and compile everything again, I should keep in mind that doing this over and over is actually very inefficient. Because what I'm doing here is I'm rebuilding the entire project, even though I just changed one little thing. Now, I do have to do this, because if I don't do this, I'm not going to be able to run things. But it turns out there's a faster way that we can make it so you don't have to rebuild the entire project every time you make one little tiny change. And the way to do that is using a Makefile. So before I go and rebuild this, let's actually build it using a Makefile. Makefile. Makefile is a very specific format, which also requires us to set our indentation to indent with tab. If we don't, this actually won't work. But what I want to do here is to be able to build molecule counter. To build molecule counter, I need to have element.cpp, compound.cpp, and main.cpp. But I don't really need these, right? What I do need, though, is their object files. The object files I can build before I combine everything together. I can individually compile each of these three things, element, compound, and main. And once I do have the object files, then I can say combine element.o, compound.o, main.o into molecule counter. Now, that's all well and good, but how do I get these object files? Well, the way to get each object file is to have a CPP file. And the CPP file will be compiled by G++ to make our O file. We'll do this again for our compound, compound, main, main. And now what we've done is we built a Makefile. And what the Makefile will do is it will look at two things. It will look at the targets and dependencies, and I guess technically the commands I'm running too. Everything on the left here of the colon is a target. It is a thing that the computer is looking to build. If it sees that that file is already in the directory and is up to date, doesn't need to be changed, then it will leave it. But if it doesn't exist, it will build it. In order to build my molecule counter, I need the object files so I can assemble them. And if the object files don't exist, well, then I need to put them together here. One thing I also want to do is use my Makefile to run the program. So here I can say run. This requires molecule counter. And if I have molecule counter, then run it. Now, if I just type make, what it will do is it will build my molecule counter, and that's it. But I can ask it to run my molecule counter, and then it will do everything. Let's watch. Make run. Oh, I still gotta fix the new line. It's for each element, it's putting a space, or a new line. Here we go. I don't want this. That's my problem. So let's notice what happens here. So I had a small correction to make in compound.cpp. The rest of my program doesn't need to be adapted. What if I do make run again? So the first time I did it, I had to compile element, compile compound, compile main, put them all together, run the program, wrong output. I made one change. What happens if I do make run this time? Notice this time I only had to correct compound.cpp. I did not have to recompile element and main because they haven't changed. So Makefile here is saving us time. It's taking the compile time into 1/3 because I no longer need to build the stuff that was already working. It's already there and fine for me. I think that's all I was asked for, right? Yeah. So now I have a Makefile and now if I just do make run, everything's up to date, so it just runs it directly. I don't even have to build anything. It's already ready to go. And this cuts down a whole lot on you having to constantly tap that up key to get to the previous command, or God forbid, typing it out all again. Overall, Makefiles, although they can be clunky to build, once you have built it, can save you a ton of time. Now we can do a bit more with this, which we're going to show in a second. This is just the simplest kind of Makefile you can make, but we can improve on this quite a bit, which I will show you now. Okay, this is our final exercise. We're going to modify our Makefile rather than hard coding everything in it to use variables and some object files. We're also going to put in a phony target called clean, which will remove the object and target files so we can reset everything. Then we'll reattempt exercise 2 with the new classes. So let's take all the stuff here, copy it, and put it into exercise 4. Okay, now the first thing I want to do is this clean thing, because it actually is going to make our job a little bit easier. Oop, not UTF coded. Well, that's odd. Can't I just grab it here? Oh, sorry, I'm opening the molecule counter, not the Makefile. Okay, let's try that again. Makefile. So we don't want to have these .os and molecule counter floating around out here. So I'm going to make a command called clean. And what clean will do is it will just run some commands. It will remove, forcibly, molecule counter. I don't want that there. It will remove, let's see, what else do I want to do? I want to remove, molecule counter, and I also want to remove all the object files. Now, I don't want to remove element.o, remove compound.o, remove main.o, because it's a mess. So I can use what's called a wildcard. It basically matches anything .o. And so this ensures anything .o in my directory is gone, which allows me then to rebuild everything. Now, these dependencies, these targets are names of files. I don't have a file called clean. I don't have a file called run. So a good practice to make sure that the computer doesn't confuse clean and run for file names, which can happen, is to declare them as phony, run and clean. And what this does is it confirms that, okay, we're not actually looking for these files. These are just commands that I can use make to handle. So now when I go into terminal and I say make clean, I refresh this, you can see the extra stuff is gone and all that's left is the actual code I care about. Now, I also can improve on this further because right now I have put all the actual names in for things, but I shouldn't need to write element 50,000 times. We can simplify this quite a bit. Let's start by talking about our source files. So what are the source files we have? We have element.cpp, compound.cpp, and main.cpp. In addition to our sources, we have our object files. Now, what are our object files? It's our sources, so literally sources.cpp converted to O. .o. .o. Yeah, okay. Now, when you're working with variables in Make, there's a specific format you have to use, which is the $ and parenthesis. And so here, what this will do is it will declare my list of objects to be element.o, compound.o, main.o. And if I add more stuff, it'll get added to my list of objects automatically because of this command. I also want to have an executable called molecule counter, because it's the name of it. And now what I can do is every time I see these things show up, I can just replace, for instance, my objects list with objects. I can replace molecule counter with executable. I can do that here as well. And I can do that here as well. And now you can see I'm reducing the number of places I actually need to rewrite stuff if I decide to change my mind. If I want to change the executable name from molecule counter to something else, I don't have to rewrite it in 5 different places. In fact, let's make sure that I get it in every place. The executable goes there. That requires executable. We'll run the executable. Now, these 3 commands can be shortened into one. So each one is taking an object file, or is looking for an object file based on a CPP file. How does it work? It runs G++, compiling this. Now here's the question, is how do you get this? And there's a handy little trick that you can use to do it. Variable less than. And less than will say this thing here. If you really want, you can also do -o, $, what is it? I think it's @ but this is not necessary. This automatically works even without it. And so the less than, you can think of like, eating the bigger number if that's the thing that you learned for learning less than and greater than. The bigger thing being the one that you actually care about. And then the @ symbol here means at the thing on the left. Your left. And what this means, I can get rid of all this. Simplified all into a single command here. Each O file depends on the respective CPP file. Compile that CPP file into the O file. Let's try this out, see how it works. So now if I say make run, hey look, even though I got rid of these full lists of things, it still knows to do them because I've replaced it with all of the variables. And now I can say make clean, and it will wipe out all of that stuff. You can see it wipes out molecule counter, even though in here it just says executable. And there we have it. Now, the last thing we were supposed to do is reattempt the exercise 2 using my new classes. So let's try it out. Okay, so I got new classes, elements that can handle this stuff. We need to take argc and character pointer argv. Now I think I do want to, actually I think we can maybe try this again without all the stuff that we had the first time around. Now we do need to have some of that stuff working, so let's grab a few things from before. So in exercise 2, what things do we need to have? We definitely want to have the check to make sure they typed it in properly. We do want to, so we do want to do that. Now, do we need to do this stuff here to insert all the ones? I think we might. And I should reset my my indentation back to 4 spaces. Okay, so they've typed in the thing. We definitely need to figure out. So our goal here is that we don't want to just say string molecule. We want to actually put all this data into a compound. Call it compound C. So we are trying to take all of the things in here, build an element out of each one of them, which includes the number of that element appearing, and put them all into our little compound. And then at the very end, we should be able to say c.display, and it should show us what we're looking for. Okay, now how can we build these elements? Well, what we'll need to do is so I guess, yeah, we do need to grab the string because we need to parse through it. So unfortunately, that can't be avoided. I'm going to grab this. And I think this will help too, because this will also just handle inputting all of the ones in the places they need to go in. Okay, so now I have our molecule string. Now let's see if I can build the elements out of the molecule that I have here. So for I is 0, I is less than the molecule length. Okay. So we kind of have the same thing that we had before where we have to check, okay, what kind of letter are we dealing with? But we're going to do different things this time. So first of all, let's get a, we're going to need to start building some elements. So we'll start with element E equals a null pointer. We're going to start by not pointing to anything. If E is a null pointer, and E equals a new element. So we're going to build a new element. Okay. So I've got my new element. If molecule I, and now here again we have the different cases. Is it an uppercase letter? Actually, is it uppercase? So what are the scenarios we have to think about? We basically have to think about, yeah, is it upper or lowercase, in which case we want to add that to the symbol, or is it a number, in which case we have completed our element, we add it to our compound, and then that's that. So if it's upper or is lower, molecule I, then E arrow, what's the name of our thing here? It's symbol. And probably I should make a constructor that defaults my string to an empty string. So for that, I'm going to need to modify element.h and element.cpp. Element. Symbol equals empty string. Okay, so that should handle that issue. So it starts as empty string. I'm going to add molecule I, so it'll add the letter to the symbol. Else if is digit molecule I. Then E, what was it, number? Number is going to be, and now here I have to convert it. I think it's string to integer molecule I. So I should convert it to a real number. And that means I now have completed my element. It exists because everything has a 9 at the highest. So I can now say C dot elements dot pushback E. I have added the new element that's there, and now E can be a null pointer, so I can reset it. So if I've done this correctly, how will this work? Well, I start out with nothing, so I make a new element. If I see a letter, uppercase or lowercase, I add it to the symbol until eventually I see a number. When I see a number, I make that the number of my element. I add that element, a pointer to that element, to my compound, and then I reset my E so that I can create a new element the next time this goes through. Let's see if this works. Now I do have to update my Makefile because right now my Makefile runs with no command line arguments. So let's make sure it works with H2SO4. Okay, lots of code that we wrote, but let's see if this all works like a miracle. Makefile. Okay, I got some errors. Let's see if we can fix them. No matching function for call to stoi. So I think that's the wrong thing. Because it's a character, right? It's not a string. Molecule I is a letter. So I just need to convert that to a integer. Where was that? Yes. Okay, so this is a character. To make this into an integer, I can just subtract 0. And this should give me the actual number. I think I cast it to int. That might do it. Let's try that now. Make clean, clear, make run. Hey, look at that. H2SO4. And all I had to do is type make run. And now if I have a little change, let's say that I want to, for instance, modify the way that we print stuff. I say, symbol, like that. When I say make run, I only have to rebuild the element because that's the only thing that changed. And now it will say symbol H, symbol S, symbol O, and so on and so forth. Of course, I can put it back if I want to. And the same thing will happen. It will only rebuild element. If I clear everything up and I say make run again, now it just runs it because it's already ready to go. And that's it. So we have made some Makefiles that will handle stuff. I strongly recommend, for future reference, having your own Makefile available to you. Something like this is very convenient because all I have to do is change the source files and the executable, and I can actually reuse this Makefile for a whole bunch of different projects, which is really helpful and will save you lots of time. So thanks for watching, and I'll see you in the next one.